When you're adding and subtracting with rationals, it is very important that you have a common denominator. So we're going to start out by going ahead and giving you a common denominator and just learning the basics of adding and subtracting before we start adding non-common denominators. So to make our steps be the same as the steps we're going to use in the next video, we're actually going to start out with get a common denominator, but this should be done already for all of these problems. So since our common denominator will already be the same, we're going to be able to skip that step and go straight into factoring our denominators, listing our restrictions, which I didn't say what we need to do for those. To get your restrictions, you're going to set the denominator, any parts with a variable not equal to 0, and solve. Okay, so any chunks, any parts of our denominator that has a variable will set not equal to 0 and solve. Then, after we've got our common denominators and we listed our restrictions, after we factored, so look to make sure our denominators are the same, factor them, list the restrictions, we're going to add and subtract in the numerators only, and we're going to keep the denominator the same. Then after that, we are going to simplify if possible. So this means we may need to look at factoring the numerator. So let's look at this first problem, and go ahead and pause at any point if you need to write stuff down. Make sure you are taking all of these notes and make sure they're very good notes. So the first thing we are going to do is factor our denominators. So bring down your numerator. And if you look at this denominator, it looks like we have a GCF, 14 and 21 both divide by 7, n squared and n both divide by n. And if I take out an n from both of those, I'm going to get 2n minus 3. And it looks like I can do that on both of these. Oops, I forgot my 2. 2n minus 3. Okay, now since this n is no longer squared, that is factored. So I've factored it. Now I need to go up here and list the restrictions. So any pieces with a variable. So 7n has a variable. So I'll go over here. 7n cannot equal 0. And we need to solve this. So we get the n by itself. To do that, we divide both sides by 7. So n cannot equal 0. That's one of our restrictions. And also 2n minus 3 has a variable in it. It has an n. So we set that not equal to 0. To solve this, we would add 3 first, and then we would divide by 2. So n cannot equal 3 halves. Make sure you have those restrictions. It's very important. We're going to have to see that on every single one of these when you have a quiz over this. Okay, now we double check that our denominators are the same, and since they are, I can now add the numerators. So 2 and n and 3, and I have an addition sign. So 2 plus n plus 3. Well, the like terms, the 2 and the 3 are like terms. The n is not a like term. And since I'm adding, I don't have to change any signs. But my n is not a like term, so I'll bring it down. 2 plus 3 is 5. And then my denominator is 7n and 2n minus 3. So I added the numerators, and look, I kept the denominator the same. It's the same in all 3 fractions, back when they were being added, and once they become one fraction, it's still the same. Then it says simplify if possible, so I need to look at this n plus 5 and see, can I factor anything out of that? And since I cannot, then this is finished. So this is my final answer, along with these restrictions. You have to make sure you always have your restrictions. Okay, that one's done. Let's move on to a slightly more challenging one. Okay, so again, first thing, we need to factor our denominators. So bring down your numerator, 5r plus 44 divided by r squared minus 64. Now hopefully by this point in the year you can recognize that r squared and 64 are both perfect squares. With a subtraction here, this is difference of squares. How that factors is the square root of r squared, which would be r, plus the square root of 64, which is 8, and then the square root of r squared minus the square root of 64, which is 8. So we have r plus 8 and r minus 8. Now in this fraction, we keep our numerator exactly the same. It was the same denominator, so it factors the same way. And then we have factored. So once we've factored, we need to list our restrictions. So r plus 8 has a variable in it, so we set it not equal to 0 and solve. So r cannot equal negative 8. And r minus 8 cannot equal 0, so we add 8. And r cannot equal positive 8. So our two restrictions are r cannot equal negative 8 and r cannot equal positive 8. Now in the next step, it said we needed to add the numerators and keep the same denominator. So my denominator I know is going to be r plus 8, r minus 8. And I add my like terms. So I have 5r and 3r, that gives me 8r. And 44 plus 20 gives me 64. So looking at this, 8 and 64, now it says to simplify if possible. So 8 and 64 can both divide by 8. So I'll take an 8 out of there and make it r plus 8 divided by r plus 8 and r minus 8. Now if you look closely at this numerator and denominator, you'll notice that there's something we can cancel. So this is where we are simplifying. So can I simplify? Yes, there's an r plus 8 in both the numerator and the denominator, so I can get rid of that. So my final answer is 8 divided by r minus 8. Now remember, we cannot cancel this 8 in the numerator and this minus 8 in the denominator because the minus 8 is attached to the r. So in order to cancel this 8, we need to be able to cancel r minus 8. And this 8 doesn't have all of that stuff going on. So you can't cancel when there's any addition or subtraction tying your number to something else. You'd have to be able to cancel all of that. So since we can't, then that is done. And don't forget that your restrictions are also part of your answer. Okay, next one. Got a little bit more complicated because now we have subtraction. So when we are looking at this, we have the same first step still. We have to factor our denominator. So since the denominators are the same, I'm kind of going to factor them over here off to the side. So it looks like all the terms can be divided by 5. So I'm going to divide by 5. And over here I'm factoring the denominator, just out of the way. And it's going to be x squared plus 3x plus 2. Okay, so now I'm going to do the AC method. So x squared times 2 is going to give me 2x squared. So what multiplies to give me 2? 1 and 2. Now 1x and 2x, does that give me 3x? Yes, it sure does. So bring down my GCF of 5. X squared stays. Remember, the middle term gets replaced by this over here, what multiplies to get it. And now we factor by grouping. We factor by grouping the first two terms together and then the second two terms together. So bring down your GCF of 5, and this is going to get a little parenthesis-y, I'm sorry about that. X squared and 1x both have an x in common. When I take x squared and divide it by x, I have an x. 1x divided by x is 1. 2x plus 2, they both have a 2 in there. So when I take that out, I also get x squared plus 1. So when I factor this, I've got 5 and the x plus 1's, and then what was out here? X plus 2. And it doesn't matter which order you put those in at all. Okay, so now I can rewrite this as 2 divided by 5 times x plus 1 times x plus 2 minus 2x plus 6 divided by 5, x plus 1, x plus 2. Okay, now that the denominator is factored, I need to set up my restrictions. So the first thing in my denominator is a 5. Does that have a variable? It doesn't, so I don't need to use it in my restrictions. X plus 1 has a variable though, so we set x plus 1 not equal to 0 and solve. So x cannot equal negative 1. And x plus 2 also has a variable in it, and so we set it not equal to 0 and solve. so x cannot equal -2. So those are my two restrictions. Now I need to look at what's going on in between here. So if you look at this really quick, this is a subtraction sign, yeah? So I believe on our directions, I don't know that it said, but anytime you have a subtraction sign, you will have to do this. Okay, so when you have a subtraction sign, you will change the subtraction to addition, and what that will do is we will have to change all of the signs, in the numerator that came after the subtraction. Okay, so that's what I did here. I changed this this minus to a plus sign, and then I changed both of these signs. And I circled them just so I don't forget which sign I'm actually using, because like in front of the 6 there was a plus, put a minus. Excuse me. So I go ahead and circle the one so I just don't get confused on what I'm doing. Okay, next we are going to add. So we are going to keep my denominator the same. So it's 5x plus 1 and x plus 2. And then I need to add the like terms. So the first thing I want to look for is anything with an x. This negative 2x has an x, so I'll bring that down. Notice it's negative because of the sign change. And then I have 2 and negative 6, so when I bring that down, it's negative 4. Next thing I need to do is see if I can simplify this. So looking mostly at your numerator, because the denominator is already factored and simplified, can I take anything out of both of those terms? Yeah, it looks like they both have a negative 2 in common. So if I divide negative 2x by negative 2, I get an x. Negative 4 divided by negative 2 is positive 2. And then my denominator is still 5x plus 1, or 5 times x plus 1 and x plus 2. So now if you look closely, you'll notice that the numerator and the denominator both have an x plus 2, which means that can be crossed off, and my final answer is going to be 2 divided by 5 times x plus 1, negative 2, sorry. Negative 2 divided by 5 times x plus 1. So make sure that you're always looking at that numerator at the end and making sure to simplify it if possible. Because if you had put this into Math Excel, it would not take it, nor is this the right answer on a quiz. Okay, next one. This one has a little bit easier. Sorry, got a little bit of a cold. Remember the first step. What is the first step on all of these problems so far? Hopefully you know that it is to factor the denominator. So if you look at your denominator, this time I'm not going to have to use the AC method because there's two terms and it's not squared, so I'm just looking for a GCF. Looks like I can take 10 out of both of those. And 5m minus 3. Oh, sorry. 10 and m plus 4. Now I need to look and find any restrictions. So will I be setting both of these not equal to 0 or only one of them? Hopefully you know that we're only going to take the m plus 4 and set it not equal to 0 because it's the only one that has a variable. So my restriction is m cannot equal negative 4. Okay, now again it looks like I have subtraction, so same as the last time. I'm going to change this to addition and change both of the signs over here. Now I'll add my numerators, so 6m minus 5m is just m, and then I have plus 3 divided by 10 times m plus 4. And let's look and see if we can simplify it all. Well, m plus 3 doesn't have any like term, or doesn't have a GCF, and it's not squared or anything, so I can't do difference of squares or AC methods, so that actually is finished. Okay, next step, we are going to find the least common denominator which is also sometimes in Math Excel called the least common multiple. So what we do for this is we need to factor all of the denominators and include equal amounts of every factor in the denominator. So the first example I have is 1/6 plus 1/4. So when we are looking at this, we need to factor 4 and 6. So we need to make a factor tree when we have numbers. So off to the side here, I am going to make a factor tree of 6. So when I take 6 and divide it, I get 2 and 3. So my denominator here says 6, but that really is 2 times 3, right? And then also for 4, and make a factor tree for it, 4 factor trees as 2 times 2. So really, instead of 4, I can write 2 times 2, yeah? Okay, so what this says by include equal amounts of each factor in the common denominator. This means for my common denominator, also sometimes called the least common multiple, I need to include equal amounts of each. So this factor has a 2 and a 3. This factor over here has a 2 and a 2. So I need 2 2's in my common denominator. I only have 1, so I need another one. Okay, so my common denominator is 2 times 2 times 3, or 12. So I have to include equal amounts of each. Now, if I were going to try to make these the same, I would need to multiply this one by what it's missing, a 2, and this one by what it's missing, which is a 3. Let's look at the next one. This one is set up as a fraction, 3 over y plus 2 plus 7/5, but sometimes it might just say y plus 2 comma 5, and we need to find the common denominator. So y plus 2 doesn't factor, it's just going to be y plus 2, and 5 doesn't factor, it's a factor tree of just 1 and 5, so it just stays 5. So what would our common denominator have? Well, it would need a 5, and it would also need a y plus 2. So our common denominator is 5 and y plus 2. So if we were going to be making these, forcing them to be the same, this one would need to be multiplied by 5, and this one would need to be multiplied by y plus 2. Now this isn't what you need to do today, this is what you need to do today, but I'm just setting this up for our next section. Okay, now we're going to get a little bit more challenging. So over here, 20 factors as 2 times 2 times 5, and it looks like I've got 2 x's and a y. 15 factors as 3 times 5, and over here it looks like I've got a couple x's, and here I have a couple y's. Over here I only had 1. So let's look at your common denominator. Well, over here I have a 2, and a 5, so I know I'm going to have 2 times 2 times 5. Now, do I have any different numbers over here? Well, I have a 3, so I'm going to have to include a 3. This has a 5. I already have a 5, so I don't have to write it again. Now let's look at our x's. 2 x's here. Do we have any more x's here? Nope, I just have 2, so that's equal amounts, so they're fine. Here I have a y. Here, though, I have 2 y's, so I need another one, so I have all my pieces but no overlaps, okay? So you need to include all your pieces but no overlaps. So if we multiply this, 4 times 15, we would get 60 x squared y squared. So I hope you by now can figure out what would we need to multiply this guy by to get to our common denominator. So what is it missing? It's missing a 3 and a y. What's this one missing? It's missing a couple 2's. Oh, I'm kind of running into my next problem. On this next one, we've got a little bit more factoring to do. So if you look at this, they both have an x in common. So I can take that x out and it's x minus 2. These ones over here, though, this is a little bit more challenging. It's x squared minus 4. So there's not a GCF here. This is difference of squares. So it's square root of x squared, which is x, plus square root of 4, which is 2, and square root of x squared, x, minus square root of 4, which is 2. Okay, so now let's look at a common denominator. So from this one, I am going to have an x, and I'm going to have an x minus 2. So that both came from this pink denominator. Now over here, I have an x minus 2, so I don't need to write it again, but I have an x plus 2. That's different, so I do need to write it again. So now look, what would this denominator need to be multiplied by? This one would need to be multiplied by x plus 2. This one would only need to be multiplied by x. Okay, last one. Why don't you pause this and see if you can do this one on your own? Look and see, make sure you factor, okay? So hopefully you tried that on your own, and if you didn't, shame on you. I really want you to try when we give you time to try stuff on your own, because it's very important that you can do it now, because you're going to have to do it immediately on your homework. So y squared minus 9, hopefully we're recognizing now that this is a difference of squares. Anytime you have a variable squared minus a perfect square, it's a difference of squares. This denominator has a GCF of 2. And this denominator is just a y. So what do we have in common? Well, my common denominator, or again, least common multiple, is going to have, leave a little space, it's going to have a y plus 3 and a y minus 3 from my first denominator, my pink one. Now the blue one, is there anything new? Is there anything I don't have? Yeah, there's a 2. And then in my orange one, is there anything new? Yeah, there's a y. So there we go. That would be our common denominator. So what's this pink one missing? This pink one is missing 2y. This blue one is missing y minus 3. And this one is missing a 2, a y plus 3, and a y minus 3. Now again, I don't know that you need to do this multiplication step on your assignment tonight. However, you will need to do it tomorrow, so we're just kind of setting you up for that. Tonight you will need to be able to find the least common denominator and the greatest common, or the least common multiple. Good luck on your assignment, and let us know if you have questions.